If you have a compound like C6H6, that's called a molecular formula, but sometimes it's nice to know about the smallest whole number ratio of atoms in the compounds, and that's where you start talking about what's called an empirical formula. So in future lectures, we're going to talk a lot about empirical formulas and molecular formulas. And the molecular formula is kind of the holy grail. All right, you want to know that the benzene molecule has 6 carbons and 6 hydrogens. And by the way, that's the structure of benzene. It's an amazing molecule. It looks just like a liquid. It's not good to drink, trust me, but it does look like water. Anyway, benzene is amazing. So if you wanted to go from the molecular formula of benzene to the empirical formula, you would divide the atoms in the molecule by some number so that you end up with smallest whole numbers. All right. So C6 and H6, both of those have 6 atoms. You can divide both those 6s by 6 to get the empirical formula of CH. So CH would be the empirical formula. It's the smallest whole number ratio of atoms. C6H6 would be the molecular formula. And most of the time, that's what we're after. Acetic acid is the active ingredient in vinegar. And so if you add vinegar to something, you're actually adding acetic acid. Acetic acid has a molecular formula C2H4O2. And so again, what you want to do is you want to get to the smallest whole number ratio of atoms. So if you divide the 2, the 4, and the 2 by 2, you get the empirical formula CH2O. Now, I've been saying smallest whole number ratios. You could divide the C2H4O2 by 4, and you'd have C1/2 H1O1/2. But we're going to see that chemists generally stay away from fractions if at all possible. So smallest whole number, you just divide them by 2 to get whole numbers, C2H2O. That's the empirical formula for acetic acid, C2H4O2. So here's a question you might see. What's the empirical formula of P4O10? So P4O10 is the molecular formula, and we want to have the empirical formula. Now remember, smallest whole number ratios. So if we divide them both by 4, well, 4 over 4 is 1, but 10 over 4 would be 2.5. So you could have P1O 2.5. But again, chemists generally stay away from fractions, i.e. don't do it. So instead of P1O 2.5, let's divide both the 4 and the 10 by 2, and then you get the smallest whole number ratio, P2O5. So that would be the empirical formula of P4O10. Some molecules have what's called an isomer, and we're going to talk a lot more about this in future lectures. Now, down here on the left-hand side, this is the formula for acetic acid. It's what it looks like. And you can see there's like a carbon, and an oxygen, all right? And the oxygen is on the outside, if you will, and the first carbon's on the outside. Well, it has an isomer, which means same formula. They're both C2H4O2, but the orientation of atoms is different. So now if you look at this methyl formate, there's a carbon in the outside, an oxygen in the middle, and then this carbon's kind of on the outside. So methyl formate is quite different chemically from acetic acid. They have the same structure, they have the same molecular formula, but they're oriented different in space, and that's really, really important. Now, in the upper right-hand side, ethanol right there is drinking alcohol, C2H6O. And you can see there's like an OH on the end. Ethanol would be okay to drink if that's what you do, and you're 21 and over, 19 in Canada, those kind of things. However, you would not want to drink dimethyl ether, which has the same formula, C2H6O, but now the oxygen's in the middle. And dimethyl ether would do some weird things if you tried to do that to yourself. So don't do it, basically. So isomers, they're compounds with the same formula, but different orientations of atoms in the space that the molecule takes up. And they're very important. There's different structures, different boiling points, different ways that they react with things. There's a lot of different kind of things you can do. Acetic acid is an acid, and methyl formate is not an acid. So there's lots and lots of differences. Isomers will be really important. I just wanted to kind of throw it up there so you know kind of what I'm talking about.